Just confirm if my screen is visible.
Yes,
Yes,
sir.
sir.
Okay, so good to go. So this is from your unit 5th, and in this we have decision tree and random forest, but it's written random forest only. So I'll try to cover a bit of decision tree as well, because it's in your data mining course as well, so that you can connect, because alone you cannot read this random forest. I have to connect with the decision tree, because collection of decision trees is gonna make it a random forest. So I'll try to touch upon that, and we will see few concepts like ensemble methods, and there is something called ensemble learning, bagging, boosting, aggregation, and how we can implement through Python. Okay, so the decision tree and random forest, both, how we can implement if we have a data set, if we have a numerical data set. So we will use random forest and decision tree as a classifier. So we will have some data set which will be based on some classification. So these two algorithms can be used as a regressor as well, if you have to predict some continuous outcome. But here, using the Python, we will use some classification algorithm. We will make it a classification algorithm, and then we will try to see how this algorithm is going to predict. So first we will use decision tree, their accuracy, and then we will check it through the random forest, how accuracy has increased or decreased. Okay, and then we will decide that which algorithm is to be used and when. Okay, so if you go through the decision tree, okay, so decision tree, obviously if you see the decision tree, it means there are different trees, right? And through if else algorithm, okay, through if else this statement, we will try to try to make a decision boundary. Okay, we are trying to make a decision based on if else loop. That is why it is called a tree. Okay, so before building the concept of the decision tree, let's say if your friends wants to go to, let's say, two places we have selected, that Poland or Iceland. Okay, so now this summer few friends will say no, we want to go to Iceland, and few will say no, we will go to Poland. So now we have a confusion, right? So how you are going to decide it, right? Let's say you are a gang of 20 people. So how you people are going to decide it? So obviously you will have certain criteria. So in decision tree, whenever you are making decisions, you will have certain criteria. You will have certain nodes. So based on those nodes, we are trying to split the tree. Okay, so here we will decide what will be the parameters of splitting the tree. Okay, so just see. So some friends are saying, let's say, Poland, and some friends are saying Iceland. But how you're going to decide, right? So let's say you have two constants, two variables, and then you will decide it. First one is budget, and second one is a time, how much time you have, right? Because it's a summer time. After that you will have some colleges, and someone has to go to some office and something like that. So obviously you will have two budget constants, two parameters. One is budget and other one is time, right? And based on these two factors, based on these two critical factors, you are going to take decisions. So let's say if someone is saying, okay, I can spend only $15,000, right? So someone will say, no, I do have a less number of dollars with me, right? And there will be also a trade-off between the timing, let's say days and weeks. Someone will say, no, I only have, let's say, 7 days. Someone will say, no, I have let's say more than 15 days. So you are going to create some kind of a tree based on if and else loop. Okay, so here I'm just shown it through this diagram as a if and else loop. If you have, let's say, this number of budget and this number of times, how you are going to decide whether you want to go to Poland or Iceland. Okay, So the theory behind a decision tree is based on if and else loop, like in C++ you typically use. Okay, so decisions, how you take a decisions. Okay, so if obviously we will try to define a decision tree. So in a decision tree, let's say in a decision tree, so how we are going to define a decision tree? So decision tree can be understood as a data set represented in the form of inverted tree. Okay, it's not like the uh, roots are upward. Okay, so it's like a tree made up with a lot of combinations of this one, if and else. Okay, just remember it. It's a combination of if, then, and else loop. Okay, so decisions are typically based on if else loop. Okay, so decision tree are used in the business community. So if you people are in the marketing, let's say if you will do job in a marketing, so the job of the manager is to segment the customers. Okay, so how you are going to segment the customers? Okay, so most marketing teams across the various industry and even in the verticals run their marketing campaign after dividing the customers into different logical subsets. So whenever you're dividing your customer must be, you divide it based on some logical subsets. For example, maybe in terms of demography, in terms of their incomes, in terms of their age, in terms of their buying behavior, in terms of some psychography, some behavior, some other parameters you decide it, but that should be the logical whenever you're dividing your customers. Okay, whenever you're trying to segment your customers. Okay, so marketing teams need to run more customized marketing strategy for each of the customer segments. Let's say you have created 5 such segments. So now you have to customize your segments so that you can have a best ROI from the campaign. Okay, so ultimate game of customizing your the campaign based on the segment is to have more revenue, right? So for example, if you are running a SMS campaign, so in a previous, if you see the digital marketing, when digital marketing was on a rise, at that time people used to do this SMS marketing. So at that time, you you cannot send out SMS to every single customers, or it's like sending every same type of SMS to the entire population. It's not possible. So for that, you have to divide your customers based on the logical segments. Okay, and then only you can send out the SMS. So how you are going to filter out which SMS is to be sent to which lot of people, right? Which the segment of people. So you will use this decision tree, and then only you decide. Okay, whether you want to send SMS to this, if you have a 2 category, whether you want to send to that category or not, category 1 or category 2, that can be judged through decision tree. If you have so many numbers of category, then only also you can use this decision tree. Okay, so decision trees are, so there are maybe the variety of customers. Obviously, I have already told you, male, female, maybe some students. So you can't send the kind of the SMS to the professionals and same SMS to the students. Maybe the same SMS to the female and the same message to the male. It's not possible, right? So decision tree are most widely used to work with this type of customer segmentation. Okay, so whenever you have a work of whenever you see any customer segment problem, if you have to solve it, so first idea is to solve it through the decision tree if it is a classification problem, or even if it's a regression problem. Okay, but you also see there is something called clustering. So don't get confused with the clustering. If your data set is unsupervised, so in that case you have to use clustering. So also in clustering technique, you also do customer segmentation. So don't get confused. Okay, here I am talking about the classification algorithm. You have a supervised data, now you want to classify. At that time you will use this decision tree. Okay, so if you see the decision tree on the right side, this is a linear combination of the output. This is a linear distributions. So you will use this regression problem because we have only one continuous output here. Okay, so this is a linear distribution, but here if you see, this is a non-linear, means some data are here and this is a class 1 and let's say this is a class 2. So if you draw a line like this, you will have certain data points which are misclassified here, and if you see, there are this data point which is misclassified. Okay, but we have to capture this misclassified data points also. So in that case, decision tree, if we are using if, else, and then that statement, the high probability is that we are going to capture this data also. Okay, if we are drawing this line like this, linear combination, okay, linear line, linear separable line, we will have a more misclassified data. But if you are draw a line like this, some non-linear way of classifier, at that time we are going to also capture this data point. So I'll show you through the Python programming also. Okay, so the linear distribution and non-linear distribution, if I show you these pictures, you can easily understand that whether you want to use the regression problem or classification problem. So here the data is linearly distributed. We have only one data points which is colored, right? Here we have two data points, the two class labels, the two targets. That is why it will fall under the regression problem. Okay, so the classification type, so the work we used to do in a logistic regression case, we will also do the same kind of a classification here in decision, the decision tree. Okay, so if you have more than two classes, also you can go with the decision tree. But in logistic regression, we hardly see the multi-class problem, but we can also use it, but majority of the time it is used for the binary classification problem. If you have more than two classes, at that time we go with this decision tree. Okay, for example, if you want to classify the credit card transactions as a legitimate or fraudulent, so it's a two class. This is legitimate and this fraudulent. So in that case, we are classifying based on the transactions of the customers. So we will use decision tree. Also you can use logistic regression here, right? Classifying secondary structure of a protein, alpha helix, beta sheet, and or random coil. So here there are three classes. So just remember that here the best algorithm would be decision tree because we have three classes. Okay, categorizing news stories as finance, weather, entertainment, sports. So now if you have, let's say, some news stories based on, let's say, you have a different the corpus you have developed, because in natural language processing the data set is called a corpus. Okay, because it's in a text format. So if the news which is in the let's say in the newspaper, whether that is related with finance or it's related with weather, entertainment, or sports. So we have four such class class labels here. So here we will use the decision tree. Okay, also you can use the logistic regression, but majority of the time it is preferable to use the decision tree. Okay, and also we have support vector machine, different NLP algorithms we have. Okay, so you can use to classify. Okay, so just see how classification algorithms works. Okay, so if you see this attribute 1, 2, and 3, and this is a class, this is a class labels. Okay, so attribute 1, 2, and 3, and this is a class. Okay, so let's say model will learn first here. So 10 data points you have given the model to learn. This is a training sets. So this is a learning algorithm. So here we are using, let's say, decision tree as a learning algorithms. You can also use logistic regression because we have a two class. So here this is a class label. Label is no, yes. Okay, there are two class labels. This is a target variable, and these all are the features. So features and target. So this from attribute 1 to attribute 3 is input, and class is output. So whenever you see a supervised data set, you will have a combination of input and output. If it is a classification problem, you will see attributes, the features and target. Okay, so now we are giving this training data set to learn. Okay, how machine is going to learn. So we will say you learn this data set through decision tree, or you can say you are giving instruction to the machine that you learn this data set, training data set, through logistic regression. Okay, or other classification algorithms. And then once your model is developed, once your model is trained, then you show the training data set, the trained model, to the unseen data. The test data is called unseen data because you don't know the class labels. So once the model is trained on this data set, our model is going to classify this test data set also. Okay, so we will see the accuracy of the test once we have trained the model. Okay, so I'll show you how, obviously you have seen it, but also I will show you once you have trained it. Let's say this is 80% of data and this is 20% of the data. Okay, this is 80% and 20%. So we are giving more training data so that our model will be mature enough to do more, the accuracy on the test data would be good, right? That is why we are giving 80% of the data to learn, right? So this is a training and test data is also called a unseen data. Okay, so now let's say how you are going to split the data. Okay, how are you going to split the data attributes? This is attributes. Okay, let's say refund, marital status, taxable income, and cheat. The person, let's say he has refunded if he is single, and if let's say his taxable income is, let's say, 1.25 lakhs, he is gonna cheat or not? It's written that no, he is not gonna cheat, right? So refund, marital status, taxable income, and something like, we have drawn a tree like this. We have splitted the attributes based on refund and marital status, but we have also a taxable income. So which attribute is splittable, right? That we have to decide it through something called a entropy, right? Information gain, right? We will also see how we are going to split the tree, because splitting the tree is going to help you out in prediction in decision tree. Okay, so which attribute is to be used as a node? That is the prime, the crux of decision tree. Okay, so let's say now we are taking another way of splitting the tree is, let's say we are taking marital status up and then refund and then taxable income. Let's say a person who is married is not gonna cheat. A person who is single and divorced, who is not refunding, and their taxable income is, let's say, greater than 80k, the high chance is that he is gonna cheat. He or she is gonna cheat, right? So this is second way of splitting the tree. But whether this kind of the tree is giving us the optimum result or not, that is the case. So there could be more than one tree that fits the same data. So now this is a second tree. The first one which I have shown you was the one of the tree, but now this is a second tree. So whether this is fitting our entire model or not, that is the case. Okay, and that could be done through the information gain, or through one of the technique was entropy. Okay, so now let's say now we are trying to, this is the same case. Now we have applied this decision tree now. Okay, now we will use this tree induction algorithms. Okay, just see. So now let's say we are just starting refund. Okay, so this is a training and now this is a testing. Okay, so let's say there is one person, let's say there is a no refund available. Let's say, just read it like this, and marital status, that person is let's say married and his taxable income was 80k, whether he will cheat or not. So let's say refund is yes. If refund is yes, we are using the first decision tree, this one, okay, to work on this test data. And test data is, let's say this one, let's say 80k. Okay, let's say this one, yes, medium, and 80k or something like that. So refund is no, let's say he's not refunding, his marital status is, let's say, married, and taxable income is 80k, whether he will cheat or not. Okay, So refund is yes. If he has refunded, the high chances that he is not gonna cheat. If he is not refunded, okay, and if he is single and divorced, and if their taxable income is greater than 80K, high chances that he is not gonna cheat. But if their taxable income is greater than 80K, the higher chances is that he is gonna cheat here. Okay, and if marital status is married, there is less chance of cheating. So this is just a tree. Okay, so based on no married in 80K, whether he will cheat or not. Okay, that is the case. So this is a unseen data, and now we are creating a tree to predict whether he will cheat or not. This is the case. Okay, if you see this refund, just explanation. Okay, the refund is no, so we will create a right node, this one, edge. Okay, and marital status is married. Is a married. Okay, so so he is a married, right? Marital status is married. Fine. But if let's say refund is no, marital status is married, so he will not cheat. Okay, assign cheat to no. This is a simple, we have to draw it. Okay, because it's easy now, because we have only 3 attributes here. Okay, refund, marital status, and taxable income. So we can easily draw a tree. A person who have refunded it, and if he is married, he is not gonna cheat. Okay, this is the one test data, and we have predicted no. Okay, another way. Okay, now this was the prediction. Now coming to non-linear decision surfaces. So this is a important one, and try understanding it, what I am just trying to tell you. Let's say we have a 2 class. Let's say one is a credit card, one person is, let's say class A is fraudulent and B is non-fraudulent. Okay, and this is our based on certain attributes, we are just trying to draw this class based on transactions. Okay, so if you see, this is a non-linear decision surfaces. Okay, so in non-linear decision surfaces, there is high chance of misclassification. There is a low chance of misclassification, because if you draw a line like this portion will be misclassified, and also this portion. Okay, but here if our decisions can take the shape of non-linear, in that case decision tree and their accuracy will be higher. Okay, if I draw a logistic regression, they just draw a line like this. It's like a separating a line like a single this is, they draw like a straight line. Even in logistic regression, if they apply the logistic function, okay, the S curve, in that case also the separation of the class is through the straight line. But here they are like a zigzag, because they are using if, else, and then. That is why they are also capturing a data points if there are some class here. But if you draw a line, a straight line, there will be more misclassification. So when you see, when you apply 3-4 algorithms, let's say logistic regression, decision tree, random forest, support vector machine, you will see their accuracy, the test accuracy will vary. Training accuracy may be somehow slightly similar or maybe different, but the test accuracy will see the kind of difference. You will see a huge difference, because some of the algorithms are not able to capture the non-linear decision surfaces, because this is class A and class B. Let's say this is fraudulent and non-fraudulent. Okay, this is the crux, because in majority of your interview, they're gonna give you this kind of questions, that if it's a non-linear decision surfaces, which algorithm is the best one. So at least you can say the decision tree. Okay, because they use if else loop, so they have a high probability of capturing the non-linear decision surfaces. Okay, so when you are using decision tree, so we have a 2 phases. One is tree building phase and second one is tree pruning. So how we are building the tree. So we are partitioning the training data, obviously based on the features, until all examples in each partition belong to one class and partition is sufficiently small. So this is one phase. And second phase is tree pruning phase. Remove dependency on statistical noise or variation that may be particular only to the training data. So pruning means cutting out. Okay. So pruning the tree and this tree building phase. These are the two phases in classification. Okay. So but there will be, you know, a phase where you have to stop the tree. You cannot grow it like anything, right? So stop expanding a node when all the records belong to the same class. We have covered it. Stop expanding a node when all the records have a similar attribute. So this is the stopping criteria, because whenever you are trying to draw a decision tree, a time when comes you have to prune the tree. You cannot grow it, okay, more. So why decision tree models? Because it's fast compared to other class. Why it is a fast? Because they can also capture the non-linear decision surfaces. That is why it's a bit faster, because they also use if, else, and that then loop. Obtain a similar and sometimes better accuracy compared to other models. The reason for better accuracy is obviously the non-linear decision surfaces, because when you draw a single straight line, the high probability is that, you know, there will be higher misclassification. If your decision boundary is non-linear, the high chance is that your error will reduce and accuracy will increase. And it's a simple and easy to understand, because obviously you have to use if, else, and then loop, and can be converted into simple and easy to understand, because it's explainable. There is a term called explainable, because it's a self-explanatory, because decision tree is interpretable model. So you might have heard of a term called explainable artificial intelligence or interpretable machine learning. So the decision tree is you know, somehow falls under a gray model. Okay, it's not a black box model like neural network, and also people call it a white box model. So but I call it a, you know, it will fall under a gray model, between the white and something gray kind of a thing. And it's a self-explanatory. So it's a decision tree is an interpretable machine learning model. Okay, you can easily interpret it because they use if, else, and the then. So it's like summarizing things, so you can easily take decisions. So it is interpretable model. But whenever you use a neural network, any neural network, because they use hidden layer. So the hidden layer, how they are calculating, how they are coming up with the decisions is very it's very difficult to understand, because they use a black box. So what is happening inside a black box is very difficult for any data analyst to tell. Okay, which kind of algorithm they are using to come up with the decisions. So that is why neural networks are called a black box model. And whenever if you are using, if your, let's say, organization is using black box model to come up with the decisions, okay, that is why you know, there comes a explainability. You have to explain the model. That is why you have seen GDPR regulations, and there are different ethical AI that is involved, that is called ethics in AI. So whenever you are using a black box model, it's your duty to explain the outcome of black box model to the end users. Okay, that is why you have seen ChatGPT is banned in some of the countries. Why? Because they are using a kind of a data set, and how they are coming up to the decisions, how they are giving you the answers are not, they are not explained, they are not explaining, it's not explainable. Okay, that is why a few countries have banned the ChatGPT. Okay, because there is ethics involved in it. Okay, because whenever you are building any AI systems, the ethics is involved, because they are using a generative AI. So it's obviously a black box model. So in that case, you have to explain. Okay, so the confusion matrix. So whenever your outcome comes in decision tree, you have a confusion matrix. So how much you have predicted negative, if it was actually it was a positive. So this one C and B is a typical problem. Okay, so ultimate aim is to reduce the C. Okay, so type 1 and type 2 error. Okay, so how you are going to exploit the node, as I already told you, through entropy and information gain. So we will see it. I'll show you how you are going to split the node. So there are two criteria. One is entropy and another one is information gain. So if you see this question here, so let's say there are different segments and P1 and P2. Okay, so this is based on entropy. So we have calculated the entropy. Okay, so once you calculate the entropy, if the entropy is lower, I think entropy will be highest if a segment has a both classes in nearly equal proportion. So let's say if entropy is higher, let's say entropy is higher in 97, this one. So this is higher. Okay, so we will take this S8 segment to split the tree, because entropy higher means we have a both classes. Let's say in some cases, if let's say 80% of the data has, let's say, fraudulent data and 20% has a, let's say, actual one. So in that case, it will be a case of imbalanced problem. Also in that case, if you are building a model, your model will be highly biased. Okay, because 80% of the training data has, let's say, fraudulent data. In that case, so if you give a test data, the higher chances is that they are going to give that output as a fraudulent. That is why your AI system, when you develop the AI model, the machine learning model, that will be more biased. So biasness in the AI systems comes due to imbalance of the data, how you are collecting the data. So majority of the time, biasness in AI systems, when you develop it, the model, AI models, that is coming from the training data. So if you see the chat GPT, if you make it a query, you will see also they are biased. If you see someone shown me that they are also gender biased. So if there is a nurse, or if they are a male doctor, so they are interpreting differently. So in that case, they are biased. Why they are biased? Because the systems, if the results is coming from the training data, so training data is biased. That is why they are giving the biased data. So you have to take care of the variables whenever you are using any ML models. You have to see the attributes and also the class. There should be at least 50% of the class. If not, then 60-40 at least. You should not take 70-80% of one class and other class as a 20%. So that model will be biased. So information gain also, information gain is used to determine the best features, attributes that render maximum information about a class. It follows the concept of entropy while aiming at the decreasing the level of entropy beginning the node. So just see how information gain works. So just see the crux first. So let's say you have two attributes, gender and income band, and whether the ordered product, the client ordered product or not. So this is a class, yes and no, two class, and you have a two attributes, gender and income band. Let's say a person who is a male and his income is higher. So the person who have not ordered the product. So we have these combinations. Okay, so which will be the splitting criteria, whether you want to split the node through gender or income band. Okay, so that could be decided through the information gain or entropy. Okay, so let's say this is a test data. Now you have to predict. So a person is, let's say, male, and if their income is high, if he is going to order the product or not. If female, their income is low, if she's gonna the order the product or not. Now we have to predict it. Okay, so the overall, if you see, there are 15 such instances here, 15 such records. Okay, and there was 10 no and 5 yes class. 66% people have said no and 33% have said yes buying product. If you are dividing it through the node, if you are splitting the node through the gender, let's say 9 male and 9 female. Okay, 7 and 2 and yes and no, yes and no. So the tree representation of physical products sales from a set of a website. So now we are just dividing it through the gender. So no and yes, if you see, there is imbalance here, but here if you see in the female, it is balanced. Okay, So overall, if you are splitting the node through gender, so we have seen like two way, one is female, one is male, and right hand it is a female. And also there is a two criteria, I mean the income based, higher and lower income, higher and lower income. Okay, this is a tree. Okay, whether splitting the tree based on gender is good or not, let's see. Okay, so if you are splitting based on income, so overall 100, and low income and high income, and there is a class. Okay, and if you are splitting through gender, let's say, and 83% said yes, and here there is a 0% yes and 100% no. So I think gender is not the good way, but income is a way to classify. So based on this tree you can decide it. So these are the some mathematical calculation I have shown you. You can go and run it. This is just a calculation. So how you are going to split the node. Okay. So this is a complete way of splitting, let's say, income and gender. Okay. But here if you see the information gain, okay, sorry, information gain of gender is higher here. So if the information gain is higher, then only you have to take that. So sorry, I'm sorry. So here the information gain of income is low, so you cannot take it, but we have to take node as a gender first. Okay, because the information gain is higher. So if our information gain is higher, we have to take that node. Okay, so here there is a correction. Okay, sorry. So if you see the calculation, information gain of income is less, but gender is higher. So we will select the variable with the highest information. Just remember that, only this one. If I give you the information gain of certain variables, and if I tell you to which one to pick up, go for a higher information gain as a node to a split. So here we will take a gender as a node, and then we will split like their higher or lower income and which class they're gonna belong, whether they will purchase it or not. Okay. So there comes a concept of overfitting and underfitting. So whenever you are using machine learning algorithms, you will face this problem of overfitting and underfitting. So overfitted models are high accuracy on the training data. So obviously whenever you are training a data points, so you will get a higher accuracy on the training data. But when you test it, you will have a low accuracy on the test data, significantly low. Let's say if the accuracy was, let's say, 90% on a training data, so on a test data you are getting as accuracy as, let's say, 60-70%, or maybe the 50% also. So instead of generic patterns, if a model is learning only the specific pattern, it is memorizing the training data. Okay, so whenever there is a case of training data, overfitting, it's a case of, let's say, your machine is just memorizing the training data. It means they have memorized every single records in the training data. You have seen some people memorizing it. Okay, so whenever the question comes in the examination different than what they memorized it, their results is significantly lower. Sometimes they get failed even if they have memorized it. So this is a case of overfitting. Okay, so in an overfitted model, relatively a small change in the training data, there are significant change in the final rules. Okay, overfitted models are overcomplicated with too many parameters and need a simplification. If it is a decision tree, large tree with too many branches and rules, it must be pruned. So if your decision tree is giving you the on a training data as a higher training accuracy, just make sure that it means you are using the more number of branches. Okay, so overfitting a generic concept, it can happen to any model, any machine learning models. Maybe if it is a regression or holistic regression or decision tree, so it can happen with any machine learning model. So how you're going to see that there is overfitted model? If your training accuracy is higher and test accuracy is significantly low, just understand that there is an overfitted model. Okay, so then there comes a concept of underfitting. Okay, so less accuracy on a training data but high accuracy on a test data. So this is also a problematic. If a decision tree is smaller than the optimal depth, okay, it is said to be oversimplified and it has some scope of further improvement. Let's say if let's say depth is very low. Okay, so in that case also it is underfitting, and underfitted model learns fewer pattern. That is also a problem, underfitted models, because if your data set has, let's say, 10 patterns, but underfitted model is gonna learn only, let's say, 2-3 patterns, that is also a problematic. So it's better for a overfitted model, because they have at least memorized your training data. Here they are not memorizing your training data, but they are just, learning only few patterns out of many patterns. Okay, so these type of models are also termed as models with biases. Okay, so they are also called a biased models, because they are just a biased, because they have just learned the few patterns and they are just giving you decisions. Okay, that is why they are biased. So biasness in AI systems is a huge topic. They are also related with ethics, explainability, interpretability. Okay, so this is a huge, the biasness, how you're going to mitigate the bias in AI systems once you have developed it. That is also a problematic. Okay, underfitted models have an inherent bias in their parameters. So if your model is underfitted, it means they are by default biased. Okay, so the underfitted model is also a problematic. So in the examination I can ask you what is the difference between underfitting and overfitting. So you have to write it these points. Okay, and also you can explain why the models which are underfitted are, the inherently or by default biased. Okay, so the concept of biasness is somehow, can drive you to come up with certain research papers. So people who want to write papers in explainability, interpretability, okay, and the biasness, they can work on. Okay, so now there comes a concept of this random forest. So here random forest is one of the algorithms which can be used as regression and classifiers. But here in this class, and I'll show you a random forest as a classifier, as a classification algorithms. So random forest is nothing but its collection of so many or many decision trees. So you are just clubbing different trees together and you are calling it as a random forest. Okay, we are picking up it randomly, and because whenever you have a collection of trees anywhere, we call it as a forest. Okay, so now random forest, so we will see in this random forest the wisdom of crowd, means how a huge crowd take decisions and we will try to extract their wisdom. Okay, the ensemble methods, and it's also called ensemble learning. If you find out some research paper around it, you will see how this ensemble learning can help you out to predict a classification problem. The bagging boosting, and how you're going to boost your model, and the bagging, we will try to understand it, what is that. So a wisdom of crowd, when you say a wisdom of crowd, what we are trying to say. So let's say, suppose, you pose a complex question to thousands of random people, then you aggregate their answers. Okay, so in many cases you will find that this aggregated answer is better than the experts answers, the experts opinions. So it is called a wisdom of crowd. Okay, for example, you might have seen people asking questions, okay, during the election times. So it's like, randomly you are asking questions to different people and they are giving you some answers. So you will see some answers are repetitive and some answers are different. You are trying to club it together and you are coming up with a one answer. That is called a wisdom of crowd, right? Similarly, if you aggregate the predictors of a group of predictors, okay, such as classifier or regression, okay, you will often get better predictions than with the best individual predictor. So here the crux lies. Let's say we are trying to predict, okay, this is a, let's say, majority vote. We are trying to train a data set. Based on data set, we are trying to train, let's say we have developed a decision tree on the same data. The naive bias, this is also a classifier. They use a naive approach. Okay, and the k nearest neighbor, this is called KNN. They use some kind of a probabilistic approach. some kind of the distance measures to come up with the classification. And there is something called a support vector machine. Support vector machine is will fall under a black box model. They also use some hidden layers. Okay, so we are training on a single data set, and we are developing 4 different ML models, and now we are aggregating it, majority vote. Okay, and if you are providing a new instance unseen data, you will see their accuracy is much higher if you are training data single-handedly on a naive base, key nearest neighbor, or a decision tree. Okay, that is why it's called ensemble. You are just aggregating it. Ensemble means you are adding up. Okay, so many ML algorithms, so that is called ensemble techniques. Okay, so there comes a concept of bagging and boosting. Bagging means creating a multiple data sets through random sampling with a replacement. Building multiple learners in a parallel and combining all learners using averaging or majority. This is called a bagging. And in the boosting, we are doing the same thing, but we are using the weighted average. Weighted average means C1 cross, let's say, their weight plus C2 their weight plus CT divided multiplied by their weights and divided by CT, the number of C1 C2 to CT. This is called a boosting. We are combining it, all ensembles, and we are using the weighted average. So there is a difference between bagging and boosting. Okay, now if you see the data set here, so now before that I'm just trying to run decision tree and random forest in Python, so that you will have at least an idea how it works. So if you see this one, I'm using the simple library here, NumPy, Pandas, and this matplotlib here. Okay, and the second one, I'm importing the data set, this fintech data. So in the fintech data, if you see dataset.head, let me bring this one data so that you can see how much data points it had. Let's say we are putting 10 data points here, 10. So let me see. Okay, so these are their attributes: employed, bank balance, annual salary, whether they defaulted or not. So here 0 and 1 is there, so the one who have defaulted is 1 and the person who haven't defaulted is 0, right? So now if you see this one, we are splitting the data set into training and testing. So if you see, the test size is 20, this is 20%, and 80% is a training data. Now we are just scaling the features. As I already told you, scaling the features means we are just normalizing and standardizing, because our data set here, if you see, the bank balance and annual salary are on the 2 different scales. They are different numbers. One is in 6-7 digit and other one is 4-5 digits. That is why we have to make it into single single scale. That is why standard scaler we have used, and this is a step of pre-processing it. Okay, and we are transforming it. Okay, that is a normalizing and a standardizing. This is a feature scaling. We are scaling so that it comes into the same scale. Now we are building not a support vector machine. This is a decision tree here. We will say it a decision tree model. Okay, so this is some commands: sklearn, import tree for decision tree, and dt model 1. This is user defined, and we are training this tree dot decision tree classifier. So if you see any classifier here, this will take a help of classification. Okay, and we are fitting the model into training and testing, and this all codes up to here is for plotting the decision tree, so don't get confused. Okay, so here if I go down, I think there should be some graphs and plots. Let me see if it comes or not. There must be some plots. So here I think some plots are not coming. So let me see how they are coming. So let this run it. Okay. So I think plot is not coming. So just run it in your system. I think plot will come. So here it is not coming. So this will show you like a tree, but here it is not showing, unfortunately. Okay. Yeah, it is showing. Sorry. So this is a tree. Okay, this is just a tree. Let me just make it like this. So this is a tree. Okay, now they have splitted it. So if you zoom it out, you will see how they have come up with the different decisions. Okay, so and now we are trying to visualize it, predict it. So we have run it. Now it's a confusion matrix. So confusion matrix means let me run this one. So confusion matrix, if you see, actually let's say they have defaulted actually, but we have predicted no, they haven't defaulted. Okay, so we have predicted they are not going to default, but actually they have defaulted. So this is a case. 51 is a problematic, right? We have predicted they are going to default, they haven't defaulted. So this is 52 is not a problem, but 51 is a problem, because let's say if you are a fintech company and 51 people are going to default, in that case it will be a problematic. Okay, now we are training a random forest, so everything is same. Now we are just building a random forest classifier. So in that case, if you see, their accuracy is 96.85, and what was the decision tree accuracy, whether it was captured or not, let me see. Their accuracy is, we haven't captured it. Okay, so now if you see the accuracy, whether accuracy was captured here or not, no. Okay, so their accuracy is let's say 96, and if it is same, let me use it here if it works or not. It's which one, y test viper, let me check if it works or not. 96.85, if it is same or what. So here it is giving us the same result, but it should be different. So just you can check here. Okay, so just see here. So when we have used decision tree, this is interesting one. Up to 51, this has reduced to 48. Okay, so now the 48 is such a person who are going to default. Okay, so now we have to catch this 41. Now you have to reduce it also. So decision tree, you have seen this type 1 error has reduced. Sorry, in a random forest, but in decision tree it was 51. Okay, if you see, it was 51. So where it was 51, but in random forest it has reduced to 48. So this is a case of why we are using this decision tree, because they are collecting the trees together and they are just reducing the error, right? So that is why we are using this decision tree, the reason for using decision tree. So now coming to this concept here, we are now in the decision tree, we have made three, let's say n number of trees, and we are just aggregating it. That is why our result is, our type 1 error is reducing. Okay, similarly, if you see in ensemble techniques, let's say we have, let's say 4 features, and this is y is a label. Now we are taking, let's say x1, x3, x4 as a one set, and we are training, let's say logistic regression. When we are using feature like x2, x3, x4, we are, let's say, training decision tree, and in this, let's say if you are using x1 and x2 as a feature, if you are training, let's say naive Bayes algorithm, and we are aggregating it, then it will call it as a ensemble learning. Okay, so this is just a case of ensemble learning, because we are training different tree, or also we can train different same algorithm on a different attributes. Okay, this is a combination, this is called a bootstrap. Okay, so bootstrap aggregating, and then we are just adding it up. Okay, so the output, when it comes, the accuracy will be much higher on a test data. Okay, similar, this is simple one. The previous one I just use more visual so that you can understand. So in ensemble techniques, we use different bootstrap sample, which I have shown you, sample 1, sample 2, and sample 3. Their attributes would be different, and we are training different algorithms. Okay, we are training, let's say, in the first one, we are training, let's say, logistic regression, decision tree, naive Bayes, support vector machine, or even maybe you can train on artificial neural network as a classifier. And we are just capturing their predictions, and finally you are just averaging it out. Okay, so the final prediction which are coming from these ensemble techniques, when you are adding up, their test accuracy will be much higher, right? That is why you are using ensemble techniques. So now there comes a few more concepts on what is the difference between decision tree and random forest. So obviously these are some their definitions, but here comes there is a possibility of overfitting. So whenever you are training a decision tree, try to address this overfitting. Okay, but when you are training random forest, there is a risk of lower risk of overfitting. So their accuracy, we have seen it also, the accuracy is lower because type 1 error was 51 in this case when we have used this example, but when we have used random forest, the type 1 error was 41. And the decision tree is simple and easier to understand, and obviously I have told you decision tree is interpretable, but random forest is a more complex one. So that is why sometime also, if you see, few researchers have put random forest as a black box model. But in my case, random forest should not be a black box model, but artificial neural network should be. But you will see random forest as a black box model also. Few researchers have used it because they are complex. They are not easy to interpret. So decision tree is an interpretable machine learning model, but random forest is not. You have to explain it. So that you have to use some explainable AI models. Okay. Similarly, bagging and boosting, it's a similar concept. Okay, so if you see the bagging is one of the oldest and simplest ensemble methods. So bagging is nothing but ensemble techniques. Okay, the concept of bagging is to train a bunch of unpruned decision tree on a different random subsets of the training data, sampling with the replacement. So the ensemble technique, they are using a bagging technique. Okay, and it improves the accuracy and stability of machine learning models using ensemble techniques and reduce the complexity of overfitting the model. If your model is highly overfitted, in that case you will use bagging. Bagging is nothing but ensemble techniques, ensemble methods. And random forest, we know it. The random forest model algorithm is very robust against overfitting, and it is good and unbalanced and missing data, with unbalanced and missing data. So if you have some unbalanced data, you can use with random forest, and the concept of random forest is built on multiple decision tree and aggregate them to get the accurate result with the little bias as possible. So whenever you are using a random forest, their biasness is lower, but when you are using decision tree, obviously they are inherent, there is a by default biasness. Okay, so this is two different. So in the examination, maybe bagging and random forest can come and you have to compare, right? So this is all from my side. This was from your unit 5. Okay, so if you have any question, you can ask. Okay.